Welcome everyone to another episode of the DFIR podcast. We are here with Pete and Zach this time around to have some nice DFIR discussions and talk about one of our latest reports. Do you want to start by introducing yourselves a little bit, Pete and Zach?
Yeah. So my name's Pete. I've been with the DFIR report as a volunteer analyst for several years now. Me and Kush just joined around the same time with a bunch of other great guys. So I've been working with Zach on this case. And so this started off as a private report where Zach created an initial summary, did all the initial triage, and then I was brought in to support the transform it into a public report.
Yeah, so this report, just to add some subtext here, this report has started as a thread brief, and we made it available for our customers for the thread brief service, where we have private reports and we make them available. And some of those reports make their way into our public reports. So yeah, this is how this started. And Zach, how about yourself?
Hey, I'm Zach. By day, I'm a DFR consultant, and obviously assist with the DFR report on a few things in the background as well. So very happy to be here.
Nice. Great. Thank you very much, Zach. Yeah, I thought we can start a little bit here with discussing some of the interesting points of the report right off the bat here with the initial entry. I found the malware more eggs that they used for the initial vector very interesting. So does anybody want to go through the initial infection and some of the techniques that the malware used that I found very interesting, but I want to hear from you what you found interesting about it.
Yeah, I could take that one. So, and again, just to kind of tie it all together, initially it was delivered by basically a fake resume. That's kind of the whole point of the initial delivery vector. And it really was kind of most effective because it was targeting people that deal with resumes all the time and click and open them all the time. And it seems to be very successful when that happens, when you target someone that clicks and opens things as part of their job. This campaign has had minimal changes over since 2023, but essentially the first, I guess, part or execution chain is to trick someone into opening a zip file that had basically the initial payload in it. And the initial payload was quite interesting because it actually used a documented lolbin kind of sideload using something called IE4U init. And when that executes, it loads this file called ieuinit.inf, and that is essentially what the threat actor modified to load the first kind of more eggs payload. They actually copied that lolbin to an app data directory, so it was away from the original place that it's supposed to be in, and then that initial sideload, it's basically a sideload, creates that first morex DLL and then triggers the next payload from that point of view. It then creates a process using WMI to kind of kick off that DLL that it downloaded. Uses things like scheduled task to just do the initial execution, and also uses msxsl.exe, which was something I hadn't seen before, another lolbin to do the initial execution. So while it's a little bit convoluted, we always see these malware have kind of a bit of a weird flow when it starts off, and it can get a bit complicated. But overall, I had a pretty nice chain of executions before it started the actual more eggs malware.
Yeah, before it detonates like the main payload, it went through a lot of different stages. And what I found interesting as well was the initial LNJ file, and it had some, if I remember correctly, had some arguments over the obfuscation.
It was a nice way to, I guess, use use obfuscation and variables by just making a whole bunch of arguments that were basically word-based. So it's almost like a dictionary. And then they kind of use those words to slowly create those arguments before they actually execute the command.
And all those methods that they used, and you just mentioned here, are very well documented.
Yeah.
However, they still kept using ways to avoid detection. A lot of these techniques would trigger an alert. Maybe if someone has a good EDR or another method with a good detection rule set to be able to detect those, because they are very well documented, but it might slip through, I found very interesting the whole attack chain here. And as you said, the IE4U init.exe, it's still a documented method, but you don't see it very often. Side loading you see every day nowadays, right?
Yeah, no, this was nice to see. It was kind of refreshing to see kind of not necessarily not technically side loading, but I guess execution hijacking, which was kind of nice as well. As far as evidence goes for this, I did want to point out that prefetch was really useful to figure out those side loadings or hijacking. Obviously, if you have magic EDR logs and Sysmon, then you probably don't need to do this. But a lot of the time, as DFIR people know, you don't get that luxury. And it was really nice to see that prefetch caught that initial. It records about that first 10 seconds of execution, and we could easily see that malicious files being loaded by that first execution, which I thought was a cool little I guess technical tip.
How long did it take for them to drop Cobalt Strike, which I see here, this is the main safety framework that they used? What was the time frame here?
Yeah, so on what we called, I guess, just day one, it was really more just that initial setup of the Morex. It kind of sat there, it didn't do anything too much. By day 3 was when hands-on keyboard kind of happened. They were actively running commands, which then actually ended up deploying Cobalt Strike. So there was a bit of I guess, a lag there, which we commonly see between, that first execution of the payload versus hands-on keyboard.
And another technique that they used before we move from Morex here is the MSXSL binary that they used. It is not a very common method to establish execution. And after that, we start to the command control server that they had established. But yeah, I don't see this being used every day. Interestingly as well, they used the directory program data, Microsoft, to run some of those payloads from. Just, everything that they did, to me, it just seems like they tried to evade detection. You don't see that every day from different type of malware. You don't see that from info stealers, but you also don't see it from initial access type of malware. Morex has always been that way from what I can remember.
Yeah. And the other bit just on the Morex before we move off, that was the type perf, which Pete, I think you had a bit of a look into.
What did they do with that?
Yeah, so you're talking about the Microsoft XSL, where it's loaded the obfuscated JavaScript, which was part of the main Morex malware. As part of that sleep routine, they used type perf, which is a Microsoft utility for collecting performance data. I've never seen it used this way before, but they use that and they specified 180 seconds is their sleep period. And then from that, they could execute the Morex again. So on its own, it didn't look that suspicious. It looked okay. But then when you look at the calling process, the number of events we're seeing, I put like a time chart in there. You see 20 events, like every 180 seconds. So you see quite a lot of activity just recurring type perf all the time. And then around that time, about 1.5 days later, the Cobalt Strike kicked in then using the Red Server 32. That had a fairly unusual path as well. It was using program data, and it was also trying to use like a .ocx file extension. Again, another technique, just trying to avoid detections, just trying to pull it in legitimate paths and so on.
Yeah, that's right. I want to go back a little bit to the type perf.exe binary. Are there any guesses from you, Pete? Why do you think they might have used this binary? I know the purpose that you explained was to collect information related to the processors. According to you, do you think this might be because they are looking to see if this is currently used by the user, if the host that they have infected is currently used by the user at that time, or they were trying to make sure that they haven't infected a honeypot, or why do you think they have that task running?
Yeah, my initial hypothesis was like, oh, they must be using it possibly to inject into it, but actually the process itself didn't appear to be used in any way, shape or form. Like the parameters that were passed is used for performance benchmark, and mainly when you're working with like database systems and so on. So you've got to create a snapshot of the system performance. But when I looked at the code of the Morex, there's been quite a lot of analysis by other individuals. It is like a loop in the Morex, and then once it gets an output from that type perf, it there's an if or else type statement, and then continues. And if it doesn't get a response, it tries to do something else. I don't know if you've observed anything else, Zach.
Yeah, the only other, I guess, theory is that it's using it to sleep. Like that's it. Is it's using an inbuilt Windows function to basically sleep and then I guess execute again once that time period has ticked off as well.
Right. So it's just mostly for execution purposes to make sure it executes at certain intervals rather than anything else. Yeah, that's interesting. When I saw that, I couldn't figure out why, because I didn't read as much as you guys did. But yeah, that was very interesting. And using redsvr 32.exe, as you mentioned, Pete, was that to load Cobalt Strike, or was that as part of a different type of execution from Morex?
That
So
was
that was
the export strat command. Sorry. Yeah.
Okay.
yeah.
They created as well many tasks for persistence. But yeah, related to the lateral movement, you said around 3 days after the initial execution, we saw them come in and execute some commands. This is what we saw in the logs. What do you think? Was that the first time they moved laterally as well, around the 3rd day mark?
Yeah. So there was a pretty distinct, or the initial kind of discovery commands they were running, typical things to discover what was happening in the network. But the most interesting thing was that they specifically were targeted a Beam server, a backup server, as their first, I guess, goal. They did throughout the campaign create local accounts as well, and on each box they got to, but the first, I guess, target was a Veeam server, and quite interestingly, they used a vulnerability, so to basically get Privesk as well as laterally move to this at the same time. So the code that they use to do that is actually a modified POC code that was created by a Rapid7 employee. And when we used like something like DNSpy to actually look at the code, it actually being just ever so slightly modified from the actual POC code itself. So it wasn't a 1-to-1 that they just kind of ran. They had actually modified it quite to give it a little bit more, I guess, capability that they wanted in their code, which is really interesting. And we could line it up to be, to kind of really even see what they had added in the code as well, which we tried to include into the report.
Yeah. Yeah, I want to get back to that as well, because they modified it, but they didn't modify it as much,
Yeah.
because we saw that they didn't change some of the main components of what the script was supposed to be doing, or what, not the script, but sorry, the binary that they compiled was supposed to be doing, which is running commands.
Yeah.
Upon successful exploitation, right?
Yeah. So the initial POC was really about exploiting the vulnerability and then creating a command. And what they had added was the function to run SQL on the server. So there's quite a lot of ways to if you can run SQL on a server to execute as well as that, but they chose to basically enable a module called XP Command Shell, which is a super common thing that we see when people are targeting SQL servers or MS SQL servers, and then use that to create an actual new process, which actually created a new account. And after they created the account, they used that account to RDP directly to that Veeam server.
What was interesting about the binary itself is that even though they adapted it, like you say, they left a lot of the strings in there, including the CVE numbers. So it's quite easy to fingerprint the binary. So we created a URL looking for that. And the binary itself, there wasn't much error handling involved. So there was, if you looked at the application log, you could see the exploit when they were running it crashing, and it created a Windows error. So every time they ran it, and they were running it quite a lot, and they were passing like various parameters like Notepad, they were literally copying the same parameters from the GitHub repo. So it was hastily put together, I think, not a huge amount of testing on it, but it did its purpose, which was for them to do their lateral movement and privilege escalation.
So this is the part that I was not very sure about, because I see that they used that binary to exploit the SQL server, but in the command, they used notepad.exe, and the notepad.exe would not do anything other than basically nothing. Those commands that they try to execute would not result in anything, right?
Correct. Yeah.
They tried to do anything after that. So to me, it doesn't seem like they took advantage of that exploit at all, because they messed up, or they didn't mess up, but maybe they forgot to change the notepad.exe from notepad.exe to command.exe, cmd.exe, right? Or something else, or parcel. Did they manage to take advantage of that binary at all?
Yeah, so that notepad argument that you see in the report is essentially redundant. It's like a hangover effect from them taking someone else's code and not getting rid of it, the key parts of it, I guess. So what they did use this for, and it was successful, was at least creating a new local user and adding it to the administrators group, and then they were able to basically RDP as an admin to the server. So they did get something out of it, and they were kind of progressed from there. Yeah.
Okay, so to anyone that is looking at this on the report, when you see the CMD calling notepad.exe, this was just done because they haven't removed it.
Yeah.
But when you see next to it, what you see next to it is the SQL command, which actually worked. And at the end of the lines that we have on the report there, you can see that they are adding a new user to the local administrators group called SQL Backup. And this is what they actually use to utilize later on.
Yeah, and we were able to, I guess, validate that with a security event saying, "Hey, this new user was created at the same time." So we were able to kind of confirm that.
That's right.
Yeah,
Someone that is just looking at this would just be, okay, well, I see CMD, notepad.exe, I can verify this is notepad.exe, so I'm leaving. But, you need to pay attention at the rest of the arguments as well, and make sure you read the code and understand what that POC is supposed to do. And if you search for it a little bit, you will be able to find it on GitHub, and we'll include a link to it as well.
Yeah, the other thing to look out for is account creation from like system. So that would be very unusual. So the character tried to blend in their account names so they look like legitimate service accounts or admins. So there's a lot of backup accounts being created. So yeah, system creating SQL backup, that is a definite red flag and should read looked up.
They tried to blend in for sure. And after creating those accounts, did they favor RDP connections over the use of the C2 framework that they had on the systems? Cobalt Strike, I think it was.
They still were using RDP to kind of do the initial pivot, but once they went to a new server, they would then install Cobalt Strike, kind of maintain that access going forward. Yeah.
And one thing I think that we missed it is how they used Cloudflare, which is a legitimate binary, that they used it to proxy traffic and connect using RDP.
Yeah. So we do see a couple of these tools going around like Ngok and Cloudflare that provide that functionality of proxying traffic out to the internet, commonly over HTTPS as well. So it looks pretty normal from a networking point of view. But we saw that being established on a couple of those hosts as well. And one of the giveaways was I think we did see an RDP connection with like local hosts, which is always kind of a giveaway that someone's doing something weird with proxying as well, accessing it through a tunnel.
Yeah, the Cloudflare creates its own audit events as well. So they appear in the application logs. So if you start to see new types of logs appearing from different vendors, then that's something else to look out for. And the software is installed by MSI binaries, which were dropped in a few places. So looking for unusual installs of that kind of activity as well to take giveaway.
Looking into the execution of MSI payloads, it becomes a little bit difficult to detect those as well. From personal experience, I don't think that you can very easily find a way to behaviorally, I guess, create a detection around those type of executions using MSI exec and executing MSI payloads. That was interesting. So at the moment, we have so many different ways of them maintaining their access. We have Cobalt Strike, Cloudflare that they used as proxy. And as we will see in a second here, they try to use Pyramid C2 as well, which is a Python-based C2 framework. I haven't seen this being used before this report. I tried to play around a little bit, but I found that it was quite difficult to install, and I don't know how they managed to use it. And I think they used it for a little bit, but yeah, that was a third method for them to maintain access. What do you think of the Pyramid C2 framework?
So they had great difficulty, like you. So they brought the framework in, but they had to get a lot of the dependencies working, and it's based on Python. And they were using various tools to uncompress the zip file to TOR files. You can sense the frustrations they were having. So they tried one approach using PowerShell to try several different commands to expand the archive. So they gave up on that, and then they started moving on to using like tar and using 7-zip, I believe. But what they forgot to do is pass the parameter where they wanted the extracted files to go to. So they ended up extracting the files into like the Windows folder, Windows System 32. In total, there was like 700 files being extracted out in different places, and they were trying to find out where they extracted this pyramid framework and all the other bits and pieces. When they did eventually get it to work, they did the initial execution of him, but then they didn't utilize it at all in any context. They tried to use one of the bots, I think, built in, but they pretty much fell back to just using Cobalt Strike again. There was a lot of baked-in credentials and configuration that Zach managed to pull out, which gave a bit of insight into the attacker infrastructure as well. But
to stay a little bit on the Python side of the execution, you mentioned they brought all these files. Was these files necessary for the execution of the Python payload? So was there any reliance of those different type of libraries that they brought in for the python.exe binary to execute the main
It
payload?
was essentially like a portable version of Python. So it had, the exe. They didn't install it as like an actual program on the host. So it was just in this kind of contained portable folder, which also had a whole bunch of DLLs and pretty much anything you could think of that was required for the execution. Yeah, the actual payload itself is just simply called cradle.py. That's it. That's all it actually was. Which was actually really easy to analyze, which is much nicer than binary analysis or anything like that. It was quite nice to just see everything there.
There was no obfuscation involved when involving cradle.py. Okay, yeah, interesting. And if you bring, and correct me if I'm wrong here, even if they would have to compile the binary on their own hosts and bring it over to the infected environment, and they try to execute it, I think because of how Python compiled binaries work, it is still extracting all the necessary files to the user update directory. And
Yeah, I think there's a couple of different ways to create a Python like compiled binary. At least I'm not aware of the creating extra libraries in AppData though. That's interesting.
Yeah, I think when you're compiling that binary and you are executing it on the target environment, it's decompressing all these files that it relies upon to run. And that is just another detection opportunity, I guess.
Yeah.
You find a lot of files under the updates are related to Python. But yeah, it's very noisy. It's very noisy for sure. And that's why I'm mentioning it here. Potentially a detection opportunity. But yeah, they didn't bother with that anyway in this case. They just brought the whole Python, all the libraries and everything that makes up this portable version of Python and execute the .py file here called cradle.py.
they had a big zip file, and it just wasn't the C2 framework. They also had other tools that they brought in as well. So it was quite a big package that they downloaded. So stealth definitely wasn't one of their goals, really. It was very much get in, do the job. But it was interesting that they were looking at an alternative C2 framework, especially when they were using Cobalt Strike perfectly fine. So, but that's a trend that we're seeing across all the other cases as well, where Cobalt Strike's been quite dominant for several years, but now there's been a lot of takedowns and so on, like clamped down on like cracked versions of Cobalt Strike. Maybe they're experimenting, seeing what works. I don't know, but it was quite a risky move what they did, because if it was detected, someone could have responded to it and shut down all their accesses potentially. But
as we saw, I think one of the things that they tried was detect it, and they were trying to make sure that it is executed. I think we will see it later on. I think it was on the backup server where we saw evidence of Windows Defender being disabled. I guess, did they have any issues with having the payloads being executed on that server?
They didn't seem to. They seem to be pretty happy. I think it was more of a playbook, do it.
Just in
So,
case.
yeah.
Just in case. Great.
They literally mean the global strike payload underscore CRL.dll. That was the name of their file. So they made no attempt to blend in further down the line. So they compromised the environment quite well, actually. But as a consequence of that, they did expose their attack boxes. So we could see them when they were proxying. We could see their workstation names. So you can see those in the in event 4624 when they're doing a lateral movement. So they had machine names such as Kali, which is a well-known Linux distribution based on pen testing, really. And then I had another name, Packer P dash, then a random name. So again, that's a good baseline. If you understand your environment and you have machine names that are structured in a way that they follow a standard naming convention. So let's say workstation like WS or followed by a number, or if you've got your servers like SVR, and then you've got something like Kali or sticks out, that'll be a good way of detecting that. It often gets overlooked, and we've seen it before in other cases, attacker machines, random names that don't fit in with the environment machines.
Normally we do see things like desktop or Win or workstation, the kind of default Windows installations. But this one was a little bit more interesting because it was a little bit more unique, and it actually was even cited in an Arctic Fox case for fog ransomware. So take that for whatever it is, I guess. Like, it is. I thought it was really interesting that there's the potential that this might have turned into ransomware potentially, or the only other explanation that we commonly see is VPS boxes having the same names and kind of being copied around, which kind of dilutes that ISC pretty quickly.
Yeah, it's very difficult to tell. In this case that you read from that vendor that you just mentioned, did they highlight the same TTPs that we highlighted in the report?
There's a few common threads, like I know we haven't talked about it yet, but the get Veeam passwords, which is a super common PowerShell script that we see in pretty much every ransomware event involving Veeam, which essentially dumps the stored credentials out of the Veeam database. And it did use a couple of other things like sharp shares, which we haven't talked about yet either here, but there's a few comparisons. It was just more interesting because that was a slightly more unique like NetBIOS name than like Win or Workstation or something that's kind of that we normally see.
Yeah, for sure. It stands out more. It's a little bit more unique. Yeah, it's interesting to see those type of things, even if we're not saying they might be the same threat actor, even if it's the same infrastructure. I think this is very interesting.
Yeah, it was definitely a finding.
Very nice. And then towards the end for this intrusion, we didn't see them deploying a ransomware.
No, so they did do typical discovery of file shares. So there was some, I guess, interesting files or folders that they open, and just from the, I guess, technical side, shell bags is one of the easiest ways to tell that. So we use that pretty much all the time in ransomware cases to figure out, what they've been accessing, if they have a GUI session at least. But so we definitely knew that they were rummaging through files and looking for certain things. There wasn't a clear, I guess, indication of what they were looking for. So like they didn't do any kind of Explorer searches, or were only looking in folders that had certain, I guess, material. But this is where we get to kind of the end of this intrusion, which kind of ended abruptly. And it even involved the threat actor actually deleting more eggs from the beach host as well. So they did a bit of a cleanup at the end. And it seemed to align with when they had already kind of gone through all of the data essentially. So maybe they found what they wanted, or found that this victim organization didn't have the data that they wanted.
It wasn't worth their effort to
Yeah.
continue.
Yeah.
Yeah, whatever the criteria that they had was. But yeah, deleting the more eggs payload and deleting some of those scheduled tasks, I think, that they had running the more eggs payload is interesting. They don't want to keep getting callbacks, I guess, from that malware. I don't think they would
Clean
Yeah, exactly. I don't think it's a matter of trying to protect their malware in case it falls into their own hands, or sort of say. It's just, look, we have enough callbacks from other victims. We don't want callbacks from victims that we have gone through their systems, and we decided that we don't want to pursue.
Yeah, just on the victims and that, one of the tools they brought in was something with NetScan. In there, it was discovered that when they brought the tool in, they brought the configuration file for it. Inside that configuration, we could see the names of other victim organizations. So obviously they compromised multiple victims, and they were just being quite selective. But that's another risk. When attackers are bringing in their tools, there's a lot of copy and pasting going on, or there's a lot of changes in the configuration. There's a lot of reuse, and that's a way of tracking them about who they're targeting and what type of victims as well.
Yeah, they obviously have some good documentation on what to run and what things they're looking for. They did spend a whole day, I guess, looking for things, trying to exploit, moving laterally to other systems. They spend a good chunk of time doing all this activity. And then at the end of the day, they decided that we are not going to continue.
Yeah, that brings quite an interesting perspective, because if they're in that position where they can choose what victims to use, and they compromise a lot of them, then that is quite scary, really, because they're not desperate. There's always someone out there they can compromise and ransomware for a better return on investment. So, yeah, ransomware is going to be there for quite a while. This way.
Yeah, if that's the case, I guess there is no shortage of customers, and this is going to carry on. And our work here, I think, is very important at highlighting those TTPs, showing them to the world, try to educate people on how these threat actors use their tools to compromise environments. And I think it's very important creating detections and highlighting the malicious infrastructure that they're using, and hopefully burn some of that down and cause some disturbance to their operation.
A lot of detection opportunities. At the back of the report, there's a lot of Sigma. We've got some private ones. You do your rule as well. So it was an interesting case.
Yeah, absolutely. And thank you very much for highlighting everything in the report, and for all your work for putting this together. It takes a lot of time, a lot of effort as well, to put all this out there, all the graphs, all the information, right down to the commands that the threat actors used and all their techniques and infrastructure that they used. I'm sure our listeners and people who read the report appreciate that. And thank you very much for coming into the podcast to talk about it. A lot of the things that I asked you, I wasn't sure about, and you clarified it very well. And I hope our listeners learned something from it. But yeah, I think we covered a ton on this episode. Thank you very much, Pete and Zach, for coming in. And hopefully we can do it again soon with the next report.
No worries.
Yeah, thanks very much.
Thank you, everyone.